So I will talk about recommender system again, but I will focus on the personal price of recommender in the recommender system, incorporating the user price sensitivity into the recommender system. As I was introduced, I'm a student a PhD student in the Ben-Gurion University, and the research that I will present today, okay, thank you, is part of my PhD thesis with my advisor, Professor Lior Rakach, who is a world expert in the area of recommender system. So if we are looking like on a market, and here in Jerusalem we have a very good one, so the sellers in the market, in their nature or characteristic that they develop over time, they really feel their customers and feel the market. So they are aware to the competition, to the products that each seller is selling, the prices. They know about the trends, what is cool today, what people are looking for, what are the prices of the competitors, and also they feel from how excited you are from their product, how much will you be willing to pay. They know how to give you the right discount in order to make you buy a larger quantity or buy different products. And of course, they do all these dynamic changes in a personal way. And part of the effort on the recommender system in general is to transfer all these insights that sellers have in the real world into the digital world, and especially with e-commerce and with the very large number of consumers and products, this is a real exciting challenge. The focus of my PhD, so recommender system, is here for a while, and we heard even today different aspects of recommendation, and my focus is really looking at the product price, or a personal product price. So how can we implicitly model the price sensitivity of a consumer, or the maximum amount a consumer is willing to pay for a certain product in order to optimize promotions. So giving the right discount, the right promotion to the person to enable the conversion. So this is the goal of my PhD thesis, and this is what I will talk about today. So the hypothesis is that the maximum price that the consumer is willing to pay for a product varies among consumers. Some people are willing to pay more, some people are willing to pay less for the same product. And our challenge in recommender system is to implicitly model the maximum price, this willingness to pay, that a consumer is willing to pay for a specific product, based on transaction history either of these consumers or other consumers, and that incorporating this feature, these characteristics of the consumer into the recommender system will improve the recommendation accuracy and effectiveness. So the term of willingness to pay is a term that is used a lot in operation research, and we use this term and some of the methods they are using there and incorporate them in the recommender system. So the motivation, of course, is to improve the recommendations, so take into account not only the products that there is a good probability that the consumer would like to consume, but also offer the product with the right price or the right promotion. So like everyone who is doing research, and even in the practical data science, we know that one of the biggest challenges is to get the data. And especially here, in order to get a suitable data, we need to get, I'm looking for data where a particular product is sold with multiple prices. So I can model the price sensitivity of the consumer. And here I got a fantastic opportunity with eBay Big Data Lab. And thank you again for eBay for giving me this opportunity, because with eBay, simultaneously on every specific second that you enter eBay, you got the same product, exactly the same product, offered with different prices by different sellers, where if we normalize the country of the seller, all the products, the sellers differ by their reputation score. And for this research, I got 6 months of transactions and bids data from eBay. We normalize it for free shipping and sellers only from US. And for every transaction, we had like the date, the consumer and product ID, and the price that it was actually the price of the transaction, or if it's a bid, the price of the bid. I'm running out of time, so I will move faster. Okay, so our methodology includes three steps. The first step is we are building a generic demand curve based on all the transactions for a specific product within a specific time period. Some of the speakers before me talk about the temporal effect in e-commerce, and we really saw this is very, of course, very crucial with pricing, because pricing varies all the time. So the first step is to build a generic demand curve based on all the transactions for a specific product. Then we model the personal demand curve for each consumer based on the deviation between the product that he paid, the price that he paid for the product, and the general transactions for this product at eBay. And then in the third step, we use this the personal demand curve and incorporate it into a multi-seller recommender system. Okay, so this is the first step to build a generic demand curve for each product, and then model the personal demand curve for the consumer. So what we see here on the left side, it's actually the willingness to pay. We can call it probability density function, where on the x-axis we have the price, and the y-axis it's the probability, and the median, like the center of the distribution, is what's the probability that the maximum price consumer will be willing to pay for this product is this price. And as we see, like if we look at the blue curve as the generic one, the average one, so enthusiastic consumer who is willing to pay more for such a product, it's the grade curve. He will be willing to pay more for this product, and like indifferent consumer will be willing to pay less. So the left curve is actually the probability, the maximum price is this price, and then on the right side we see the cumulative probability, which is actually the probability that, assuming the consumer wants to buy this product, that he will be willing to buy this product in this price. And of course here, as the price increases, the probability decreases. So here we have a kind of assumption or a model how to model a consumer willingness to pay, comparing to the generic or other consumers in the market. So this is very nice for the product, for the transactions that the consumer already did. But what is always interesting is what's the price sensitivity of the consumer for new transactions, for new products that he didn't see yet. And to predict that, we use the machine learning algorithms, specifically the matrix factorization, context-aware matrix factorization. I will talk about it. And like instead of predicting like what's the rating the consumer will give to a product, we predict here what's the price that he will be willing to pay. And by price, we don't look at the absolute price, but we look at the percentile, at the delta, like the deviation of the price this consumer will be willing to pay, comparing to the average consumer in the market. Okay, so that's how we predict the price that the consumer will be willing to pay for unseen products. Using a matrix factorization algorithm. Here, we also, what we saw is that of course, the seller reputation influenced the maximum price the consumer is willing to pay. So we included the reputation score of the seller as a context variable within the matrix factorization, and we use here a quite common algorithm, context-aware matrix factorization. Okay, and here are a little bit some initial results. So one of the things we wanted to look at, to evaluate, is what's the distribution of the prices of the willingness to pay. And we looked at the different distribution based on the data set that we had from eBay. We couldn't find one distribution that perfectly matched and passed the Kolmogorov-Smirnov significant test, but the logistic distribution was the most compatible one. And here you can see different characteristic of the data that we have comparing to logistic distribution. On the right side, we looked at the willingness to sell. So like in eBay and in other e-commerce sites as well, the prices are changes all the time. So we looked at specific sellers and specific product, and we looked like at the cumulative distribution of the prices. So what we can see that sellers with lower reputation, like the yellow curve, are willing to sell the products with lower prices than sellers with higher reputation that sell the same products with higher prices. Okay, so the first prediction that we did is what will be the willingness to pay of the consumer, and what we assume here is that when we do a transaction, the price of the transaction is the willingness to pay for this product. Of course, it's not accurate because maybe you're willing to pay more, but at least we know that you're willing to pay this price. With auctions, it was even more. It was nicer in the sense because, like, we know what's the highest bid that the consumer was willing to provide. And here we see the results so the prediction here was what's the maximum price the consumer will be willing to pay for a specific product. And we looked at 3 different models. Like the baseline was the median, the average price in eBay at that specific period, and we compared it to a matrix factorization to predict the willingness to pay without taking into account the seller reputation, and context-aware matrix factorization, where we took into account the seller reputation. And what we can see is that, and we looked about thousands of transactions in the test set. We looked at 2 measures. One is the MAE, the deviation from the actual transaction price, and WAPE, which is like a weighted error, which give different weights according to the price of the transactions. And what we see that the accuracy is quite good. Like we had, if the average bid price is $28 and average transaction price was $47, so our deviation was like about 10% from the actual, from the average transaction price. And that our model is much better than the baseline, than using the median price, especially, of course, with the auctions, because with the auctions, we have like the variety of prices. It is much wider than with the transactions, because with transactions, it's true that the price varies among sellers, but it has quite narrow range. Where with auctions, some people are offering very low prices. So you can see here the results. So our prediction accuracy, let's say it's less than 10% from the actual price that the consumer is willing to pay, and it's much better than providing just the median, the average price, as the willingness to pay. So this was the first stage of the prediction, and the second one was to incorporate now this information into a recommender system. And similarly, I think for one of the other speakers, so we are doing a ranking of the offerings, and we set the ranking of the offering based on the multiplication of the probability that the consumer would like to buy the product, and the personal demand, which is actually what we calculated in the previous step, which is like what's the probability the consumer will be willing to pay this price, assuming he likes the product. And okay, and here we had also the problem that we saw only like the positive examples. So we did some negative sampling, and for a test we included in the test set not only the transactions that were actually done, but also for each consumer we also added negative examples, all the offerings that were purchased by other consumers on the same day, and we did it only for the transactions, not for the auctions. Okay, so these are the results. So again, here for a baseline was the matrix factorization, so not taking into account at all the price sensitivity and the price the consumer will be willing to pay. The second method was to take only the matrix factorization and the personal demand. The third method was to combine also so do context-aware recommendation, take into account the seller reputation when we compute the probability that the consumer would like this offering, because we know that especially online, consumers are very sensitive to the reputation score of the seller. Okay, and the fourth one was only the seller reputation. And you can see that the third option, where we take into account both the seller reputation score and the personal demand graph, provided the best results. So what we did here, like for every consumers, out of more than 1 million offerings, we offered 10 offers with the highest ranking, and we look at the recall precision and F-score, and we see that by combining both the personal demand and the seller reputation, we got the best accuracy. The numbers here looks quite low, but relatively to this amount of possible offerings, it's good results. On the lower graph, you can see what is called MPE, which is the mean percentage error, where we compare the error of this method to the baseline method, which is providing recommendation, matrix factorization recommendation, which doesn't take into account the price sensitivity and the seller reputation score. And you can see that this method is much more efficient than the other one, both for recall and for precision. So, okay, this research with the very rich and unique data from eBay really shows us that, as we all know, that the willingness to pay indeed varies among different consumers, and that it is possible to predict the willingness to pay of a consumer based on transaction history of this specific consumer and others and other consumers or transactions which take place. When we incorporate this price sensitivity or willingness to pay into recommender system, it improved the accuracy of recommendation, and this is, by the way, consistent also for other data sets that I looked at, and also other research. So taking into account the product, the price sensitivity of a consumer improves the recommendation, and of course it enables us to optimize promotion and to give the right promotion to the right consumer in order to improve conversion as well as other business KPIs. So that's it. Thank you.